Hello everyone! Today we are going to present the RESPOND project on behalf of NUI Galway, one of the consortium participants. My name is Dayanne. I am a PhD student at the NUI Galway and my research area is measurement and verification applied to smart grid.
And I am Paulo Lissa, also a PhD student from NUI Galway, and my research area is about machine learning applied to smart grid. In this presentation, we are going to show you a project overview with information about the consortium structure, the pilot sites, use cases, and the KPI calculation, and finally, the main results, challenges, and lessons learned. Starting with the project profile, RESPOND means Integrated Demand Response Solutions towards Energy Positive Neighborhoods. It was funded by the European Union under the Horizon 2020 program. The project started in 2017 and finished in September 2020, and the objective was to deploy and demonstrate an interoperable, cost-effective, and user-centered demand response solution. The solution was composed of residential automation, control, and monitoring tools to integrate a cooperative demand response into legacy management systems. Now, I'm going to show you a short video that explains the main idea of the RESPOND project.
What is needed for European families to use more renewable energy in their everyday life? For starters, it should respond to changes in energy supply and demand using existing technology like smart meters, storage and demand response. However, demand response initiatives have only been available for major energy users like factories until now. RESPOND is a Horizon 2020 project aiming to bring demand response capabilities to neighbourhoods across Europe. To exploit this untapped potential, Project RESPOND will deploy an interoperable energy solution at the unit, building and neighbourhood levels. Using smart monitoring and load balancing technology, RESPOND will help consumers leverage new energy-saving opportunities. Look for RESPOND in 3 pan-European pilot sites: the Danish city of Aarhus, the Aran Islands of Ireland, the city of Madrid, Spain. Learn more about Project RESPOND at project-respond.eu.
Moving to RESPOND Consortium, there were 11 partners from 5 different countries. There were 2 energy providers, 4 universities and research centers including NUI Galway, 3 technology providers for home automation and analytical services, and 2 local representatives in the Irish and Danish pilot sites. The energy provider FENI was responsible for the Spanish pilot. A little bit more about the pilot sites. The Irish demonstrator was deployed in the Aran Islands, where we had individual dwellings with equipment such as PV panels and heat pumps. The Danish pilot was deployed in a social housing, where occupants shared a community PV generation system. Finally, the Spanish pilot was deployed in private apartments. Each of the pilots had unique characteristics, allowing a better analysis and comparison of DR models. The architecture of RESPOND is not the same for all the houses, but this is a generic representation of the solution deployed. The houses were equipped with individual meters and smart plugs, and also temperature and CO2 sensors for comfort analysis. All the information collected is centralized in the gateway, which exchanges information with the RESPOND platform. The RESPOND platform processes the information and provides optimal profiles of energy usage, which can be automated actions, for instance, remote control of a heater smart valve, or suggestions sent to end users through the RESPOND app.
In this section, I'm going to describe the demand response use case applied in the project. The first use case is called the impact of the RESPOND app to the user. It was applied in the 3 pilots, and the objective was to evaluate the impact of the RESPOND app in the user behavior in terms of energy consumption and indoor air quality conditions, right after they have access to the data provided by the app. The second use case is called Maximize Autoconsumption, load control switches for appliances. where the objective was to increase the use of energy in-house through load control switches for appliances, maximizing the use of the energy produced by PV panels in the Aran Islands. The use case 3 is called PV panel, optimal profile of use for heat pumps. The objective was to increase the use of energy in-house through implementation of heat pump optimal profile, maximizing the use of energy produced by PV panels and maintaining the thermal comfort in the house. The use case 4 is called peak shaving, where the objective was to decrease the use of energy from an aggregated number of dwellings to avoid peak periods. The idea was to create a virtual scenario for a future aggregator. Incentives were based on saving CO2 emissions. The use case 5 is called load shifting district heating system. The objective was to have a load shifting in the heating energy demand through temperature setback in the morning hours. Use case 6. Maximize outconsumption from grid-connected PV panels. With the objective to optimize consumption of locally generated PV power, the aim of this use case is to optimize self-consumption and avoid exporting excess PV power generation to the grid. Use case 7 is the price-based demand response for electrical energy consumption. The objective was to support the MaREI households in performing demand response in relation to electricity price. The main idea was to change the electricity load during a certain period with financial incentives. Finally, use case 8 is called solar thermal panels management, where the objective was to maximize the use of thermal solar heat water system, decreasing the gas usage for domestic hot water. Now, I'm going to talk about the validation process. The KPIs for the quantitative calculation were defined based on the project objectives. The main categories were energy, CO2 level, demand response, economic savings, and comfort. For the calculation, it was used the platform from one of the partners, called Dexma, and also the information from the project database with external tools. After the project assessment, the results were analyzed by pilot and by use case. In Ireland, the customers were involved in manual actions, achieving more than 10% of energy savings in all use cases. In this pilot, there is also a possibility of using automated actions, what could bring additional savings and load shifting. One important result of the qualitative analysis was that the individual ownership of PV panels resulted in higher engagement in the demand response action. In Denmark, it was possible to see the results for both manual and automated actions. The results for the automated action presented only moderate negative impacts on users' comfort. The manual actions in this pilot showed that app notifications with recommendations on demand response actions can be a useful tool. In Spain, the outcomes of the price incentive for rescheduling the electricity load were analyzed. The project participants effectively changed the demand during the specified hours, especially when they were contacted previously about the event. During the validation process, some challenges were faced, especially regarding data quality. The restrictions we are facing in 2020 due to COVID-19 affected the behavior and the energy usage in the residence. In RESPOND project, some impacts that were seen in user behavior affected also prediction models, baseline values, and equipment installation and maintenance. The first chart shows an analysis from the International Energy Agency for Madrid during the first weeks of COVID-19 restrictions, where the peak hours were similar, but with a variation on the energy usage during the weeks. The second chart shows the consumption in the RESPOND MaREI pilot. In this case, it's possible to see an increase in energy usage during this period of lockdown. And now, some lessons learned and challenges faced in all pilots. The first one shows that the most important actions should be the ones that impact the user experience and also leverage the user engagement. For a successful demand response project applied in residence, the user engagement is one important topic. Without the feedback from the participants, some actions may reduce the user comfort, what will make the participant avoid doing more actions. The second is that you should keep monitoring the status of the measurements and set up alarms to know as soon as possible when data is being lost. In residence, there are many factors that may cause interruptions in the internet connections. Identify fast when data is missing can guarantee a more accurate validation process. The third is to involve the users in the design of the mobile app. Collect the feedback from the participants in the first versions can improve the user engagement. And the fourth is that sometimes there are problems that cannot be predicted, and it is important to be ready to react as soon as possible to guarantee the expected result in the project. As an example, the COVID-19 restrictions. I hope you enjoyed this presentation. If you want to learn more about the project, you can access the website or contact us via email. Thank you very much.